Tom here with Granite Custom Cabinets. This is part of our Woodworking 101 series, and today we're going to talk about the table saw. This is arguably the most important and most commonly used tool in every woodworking shop. The proper setup and installation and calibration of this tool is critical to precise results and your safety. So next we're going to talk about the measuring tools we need in order to set this machine up correctly. So the first tool is a precision machinist level, because the first thing we have to do with our table saw is we want to put it where it goes. We want to precisely level this machine and bolt it to the floor. Now I know a lot of you are using mobile bases. I would not want to use a mobile base on a table saw, so the next best thing is you have tape on your garage floor or something marking where your mobile base goes, and you attempt to level the machine as precisely as you can. The reason why leveling this machine is so important is because if you place the base of this machine on an uneven surface, it's going to warp it. And if you have a warped machine, you're never going to get true results out of it. And the clearance on all the components, the way your trunnions align, all that stuff is not going to work out. These things were designed to sit level. So the first tool we use is a precision level to do that. The next tool that is absolutely critical to precisely paralleling your blade and fence is a dial indicator and this special little base that rides inside of your miter gauge groove. And so we can run it up and down the groove, check the parallel on the fence, flip it around, and we're going to check the parallel on the blade. Lots of different people sell these tools. I'm not going to mention any brands here, but they're widely available. The next thing that you need in order to precisely align your saw, this is a precision plate that's designed to go into either a 5/8 or 1-inch saw arbor. You need to have this in order to properly align your saw. A blade will not work because the blade is hollow ground on the inside for tooth clearance. The other tool that's very important to achieving precise results is a machinist square. Machinist tools are typically certified to be within a certain tolerance range. I think this one's certified to be within like 2/10,000ths of an inch square, something like that. This level is certified, I believe it says 2/10,000ths of an inch within a 10-inch span. Last tool you need, not absolutely necessary, but really nice to have, is a pair of calipers. We use these. The calipers are the final judge of what exactly a measurement is in this shop. So if the caliper says it's 5 inches, it better be 5 inches on the radial arm, 5 inches on the table saw, and 5 inches on the planer. This tool will really help you up your game. Now, let's talk about how we go. So now we level our machine. Right now we have the level shown to indicate our side-to-side level. This step's kind of self-evident. You want to level it side to side and front to back. Now if you own a machinist level, what you are going to figure out is that more than likely the surface of your saw top is probably not perfectly flat. Woodworking machines are not made to the same tolerance as metalworking machines. So I simply like to determine my level with a machinist level right in the center of the machine. So we want to level this machine with non-compressible shims. We've used a mixture of sheet metal and some pieces of copy paper, and precisely got this machine leveled and bolted to the floor securely. So next step, we're going to check our blade parallelism. So we've bolted our precision plate into the arbor. You want to tension your arbor nut the same as you would when you're tightening your blade. That's especially important if you're using blade stabilizers because they do compress slightly. That way it's as true as it's going to be. Also make sure the surface is dust and burr free. So we bolt that thing in there, we adjust it to the proper height, and then we're going to take our dial indicator. We're going to take our dial indicator here and we're going to run it front to back. So we'll bring it to the front of the saw. I've already zeroed out the bezel. Then we're going to run it through to the end. Now, this is showing that I'm approximately 1/1000th of an inch tighter at the back of the blade than at the front. So if your indicator goes clockwise, it's going towards it. If it goes counterclockwise, you're going away from it. In order to adjust your blade parallel, what's actually going to happen here is the trunnions and the blade are going to stay stationary relative to the base of the saw. And what you're going to do is loosen these 4 Allen bolts that hold the tabletop to the saw and gently bump your table until your miter gauge reading with the indicator reads perfectly parallel to the plate. This is kind of a tricky process. You don't really want to loosen everything completely. You don't want it bouncing or moving too much. Now, before you begin the process of adjusting your fence to be perfectly parallel with the miter gauge groove, this is what we refer to as our reference point. You want to get it roughly square to the table. That way, even if your indicator arm was to drift a little bit, you're not trying to read off of an angle, which a small amount of up or down travel could greatly throw off your horizontal reading. Now, we are going to run our dial indicator up and down this fence to check the parallel. So I have zeroed out the bezel here at the front of the fence. Now we're going to slide it down to the back. Now, what I'm more concerned about is that I have basically the same reading at the very front and the very back. With a fence liner, it is going to vary slightly. This is also another way you're going to discover whether or not your fence has a banana to it or some bumps in it. We'll go into fence liners in another video under advanced table saw techniques. So basically, you're going to adjust the set screws on this fence until you have exactly the same dial indicator reading front and back, or I should say front and back. Now, some guys like to put a little bit of heel on a Bismarck style fence. I don't do that. The reason why is pressure from what I'm cutting. These fences have a little bit of play in the mechanism and it will naturally heel on its own. I don't know if you guys can see this in the video, but right now my indicator is at 0. I can easily move it several thousandths of an inch. There's my heel right there. So one of the trickiest parts about your initial saw setup is getting your fence rail perfectly at 90 degrees to these miter gauge grooves. So the best way I know to do that is to use a little bit of trigonometry. So we can do the 3, 4, 5, 6, 8, 10 measurements. So if we go 6 inches on one leg of a 90-degree triangle, 8 inches on another leg, the hypotenuse should be exactly 10 inches. And that's, how would I call it, an expandable reference. Any multiple of those numbers, the same multiple, that measurement works. So one way to do it is to have somebody cut you a perfectly square piece of plywood. You can also do it that way. Next, we're going to talk about the proper amount of tension on a Bismarck style fence. So our fence rail being a steel tube extrusion, or welded tube or cold rolled tube, not sure which it is. We don't want to apply too much pressure squeezing on this. We can actually dent it. We don't want to do that. So we want our fences obviously tight enough to where even when we're exerting a fair amount of force, and by that I mean up to 40 or 50 pounds laterally against the fence, that thing's not going to slide over on us. I've had it happen, and it's not fun. So sometimes you got to make a few modifications. On this particular fence right here, I ground the ends flat to eliminate how much spring was possible in this fence, because I really don't want that much spring to it. I have basically set up this fence so that with the cam and the all the way down position fully locked, it's at the tension that I want. After you get this fence perfectly parallel and your tension adjusted properly, I highly recommend using blue Loctite or hot melt glue to hold everything. Now let's talk a little bit about cursors. So what I like to do, we've tried to standardize all of our blade thicknesses. We use a 0.120 kerf blade, which is like 5/1000ths under an eighth of an inch. So this cursor has been set so that a ripped piece of wood comes out to within about 5/1000ths of an inch of nominal. Now as your blade gets sharpened, that's going to also change things by a few thousandths, but we don't worry about that too much. Alright, last few things I want to leave you guys with. Your table saw is going to come with a factory insert. These things usually have way too much blade clearance, and they're not safe. They can lead to small offcuts, falling down in there and getting jammed. Your drop cut can also hang up on them and then get spit back at you. So we only use the factory insert for operations where we have to raise a blade up extremely high, or use a different blade in the saw that requires different width. I highly recommend what's known as a zero clearance insert. These are made by various manufacturers. This one's phenolic. You do have to cut your own slot through it. We'll cover some of that in our advanced table saw video. Last thing, arguably the most important, push sticks. You only get 5 fingers. So this particular push stick, it measures 5 inches wide, 10 inches long. This is a 3-inch heel on it. This is the design that I was taught in wood shop 33 years ago, and I feel it's the best push stick design there is, because it gives you total control over the workpiece, the pressure. You can push down and in on it. It's very stable, unlike push sticks that have a notch and require you to hold it at a 45 degree. This piece lets you push a piece of wood down if your blade's kind of wanting to push it up towards you if your wood's warping. So I feel this is the best push stick design. Alright, thank you guys for watching this video. I hope that everything I've shown you today helps you out, keeps you safe, and I think you're going to find that a properly tuned saw, the cut quality and the level of precision you're going to get out of that machine is just a world of difference. So if this video helped you out and you enjoyed watching it, please like and subscribe, and stay tuned to our channel for more upcoming videos.